So we've got a great event lined up today. As usual, we're trying to cram a lot into the hour that's allocated. Not certain we'll have much time for networking at the end, but we will hopefully have time for some good Q&A. So let's get on to the agenda slide before we move on. Show the agenda slide, Mo. There you go. Okay, so I'm doing a brief introduction. My name is Andrew Faulkner. I'm the president of the Ottawa Product Marketing and Management Association. We added an extra M in there. I always get it the wrong way around. Our main event obviously is all about AI. What does it mean to you? And we're very honored to have Cliff Ellement as our keynote speaker today. We'll then come back and have some Q&A, and then I'll hand over to Amanda, who will give us some very exciting news on our upcoming meeting, our March meeting, and then we'll wrap and we'll go all off into the wilderness. Okay, thanks, Mo. So just a quick word about volunteers. So that this is the mugshots of some of the key people that have helped put this event and many of our events together. Hala, you all know, say hi to Hala, say a big thank you to Hala. Amanda, Mo, that's holding the technical wheel for us all. So if it all goes horribly wrong, it's all Mo's fault. If it goes right, it's everybody else's to be praised. We also have Shinzi. We have Michael with us. You all know Michael Bergen. Did I miss anybody there? I think that's it.
Jerome.
Jerome, yeah. Well, Jerome's not with us today, I don't believe. Is he?
No, he's not. He's not. And Dinesh neither.
So a big thank you to all our volunteers. And you can see there's a space, a little red icon there. We're always looking for people to help out in many different types of capacities. It's a great opportunity for you to give back to your community. You may meet some new people. You may also get to develop skills that maybe you wouldn't use. So it's a great opportunity to get involved. So let us know if you're interested. Okay. Thanks, Mo. And then sponsors. So bringing in an event as awesome as this one, and the one in the picture there was Product Camp in 2019, when we were all alive, is not free. We have a website, we have this web tool, so we do have some bills. So a big thank you to our sponsors. It builds, okay. So Pragmatic Marketing, we've been associated with them more or less from the beginning. Invest Ottawa, this is where that Product Camp 2019 took place, and VanillaSoft. So a big thank you to them. And again, there is an opportunity for you to sponsor us. It doesn't need to be a lot. My dog is about to start going bananas in a minute. So move on. Mo. There you go. Okay, so one final thing about the OPMA mentorship program. This is something that I believe in passionately. Product management and product marketing, they're not always taught in educational institutes. It's usually a job that you grow into over many, many years and develop many, many scars and war wounds, and it's a job of experience. Having said that, the institutes are catching up now, and there are a few courses available, but still you can accelerate your knowledge and your learning, and you can increase your personal value absolutely by joining our mentorship program, either as a mentor or a mentee. So if you're interested, please shout out or go on our website and fill in the form. We look forward to hearing from you. Okay, so now very quickly on to our main event. So unless you've been living on a rock, or maybe you've been stuck in your house for 2 years and not going outside, you can't not have heard of AI. It really isn't a case of when or if. It's here, it's now, it's all around us. And I think arguably, of all the technologies that's been introduced during what they call this fourth industrial stage or the digital age, I believe that AI will have the single largest impact on society as a whole. We're very fortunate to have Cliff to walk us through this and walk us through his AI experience. Just a few words. I first met Cliff about 5 years ago through OPMMA, so that was one of those good networking events where you got to meet some good people. Certainly Cliff did. I'm joking. And at the time, it was obvious how passionate Cliff was about AI. We had lots of discussions. a few about education, educational possibilities for OPMMA, but mostly about AI. And after we've had our coffee and we parted, I went home and kind of binged on Netflix. Cliff took to Coursera and a whole manner of AI related courses and really developed his knowledge and skill set in that area. And I guess he's the future Cliff is thanking him now for all that effort now that he's landed a great position as head of AI solutions at Think RF. So with that, Cliff, I'll hand over to you and make us all experts on AI.
Make you an expert in something. Okay, so I'll just share my slides here. Tell me if you see it.
Yeah, it's coming up.
Can you see it?
Yep.
Yeah.
Fantastic. It worked smoothly. Okay, so thanks very much, Andrew, and the OPMMA team. Very happy to be here. What I'm going to talk about is, even though we're saying AI, I'm going to talk about what it means to the product manager. That's what we mean when we say you. We're all here today as product, or interested in product management. So I'm going to talk about the product management role in AI. I'll dig a little bit into it, but I'm going to be very high level. If you have any questions, want to go down a little deeper or deeper into AI concepts or things you heard or different aspects of it, we can leave that to the end. As I'm going through the presentation, if you have any clarifying questions, we can take them real time, or we can just take them later on. I think, Andrew, you mentioned that people can put questions in the chat if they want to, or wait until the end. Maybe we can open up the floor if we have time to do that.
If they could put them in the chat, that would be great.
Yeah, that'd be fantastic. Okay, so as Andrew mentioned, got very much into AI. A lot of my previous background in education and work kind of leaded up to this, where I am today, because it's not just about AI. I'm not becoming an AI researcher. I'm applying artificial intelligence and deep learning capabilities in order to do a specific thing or things at Think RF. And we'll talk a little bit about that and what that means to the product manager, because this is the way we need to think about how you apply AI to new products and services as you're developing them. So more specifically, what we're going to address today is things like about what exactly PLMs or product managers should know about artificial intelligence, how and understanding how AI can be applied to solutions, or how they're actually being applied today to different solutions. How are companies using it? How are different products using and capabilities are using AI today, and how does that apply to your company's product line or service? Domain knowledge and application and AI applications, very important aspect of integrating AI and your product and the problem you're trying to solve. We'll talk a little bit about that later as well. Understanding the AI program risks, very, very important. There's time considerations to get the AI running from a development perspective. There's technology choices, all have different impacts to the project time, cost, and benefits. And obviously, there's going to be a cost. Every time we're talking about product management and new product introduction, it's all around the benefits and cost analysis, right? So that's something we have to always have to consider. And the product manager, like any other project or product development activity or initiative, has to be the gatekeeper on the business case. So it has to understand the cost, the risks, and the potential benefits. It always comes down to the product manager as well. Managing AI products and new products is a very important aspect as well. Now, after saying all that, there is something interesting happening in the market, because like we were just talking just before the presentation, we were talking about there's AI in everywhere. Unless you were under a rock, you've seen it. But what's actually happening out there? And the news isn't that great, I mean, to be honest, but this is actually true for any new technology being introduced into corporations or new product lines. The vast majority of AI, data science or AI projects don't meet the expectations they sought out to meet at the beginning. So it's typically around 80%. Now, I've seen the same statistics in other new workforce engineering or business process engineering activities, 8 out of 10. It's typically the case, the 80-20 rule, and it's true here today. So the question then becomes, well, then how can AI or how can the product managers improve AI product and services success? And that's what, and if you're going into this AI initiative, you're building a product, there's certain considerations that we're going to talk about, and hopefully you can get something out of today's conversation. Now, after saying that, there's actually more than new products being introduced. People are introducing AI for business improvement in their own companies. So even though a company might not be building an artificial intelligence or deep learning capability for their customers, they may be applying it internally. Now, Mike was just saying before about Salesforce.com. So there's sales using AI, HR, marketing, customer contact systems, finance, all that are using artificial intelligence. Now, it could be as easy as just bringing in a piece of a new capability into the product, or if you're actually trying to change your business process and bring in artificial intelligence and bring in an AI team to create a new internally generated capability for business improvement using AI, that's where a lot of problems or a lot of unsuccessful projects occur as well. It's not just a product introduction, it's also internal AI teams building new business processes for internal use as well. Just want to make that clear. Today, we're going to be talking about the new product introduction, but there's yet another discussion about how to build teams internally for corporate initiatives and be successful in deploying AI for internal processes. So what do we do at ThinkRF? I'm going to talk a little bit about this for a minute because I want to give some insights to why we are using artificial intelligence. Well, ThinkRF is a spectrum, or we build spectrum monitoring equipment for people who want to understand what's happening in the RF radio frequency domain. Our customers are wireless providers, regulatory providers, security companies, and government agencies that are looking for things for protection and defense organizations as well. It is a very technical product, so we actually build the spectrum analyzers and design and build them, and we also build the software associated with being able to measure, detect, protect devices that are using wireless technology. And there's many use cases which we'll not get into. But from an AI solutions perspective, some of the areas that AI can be used in the RF domain, and many of these we're actually developing within ThinkRF itself, is using artificial intelligence to improve the existing capabilities we have for detecting interference or nefarious jamming transmitters. And now, as you know, when 5G is being rolled out, it's becoming a real catalyst for the last mile. The last mile is becoming more and more wireless because it's faster, better, cheaper, it's more flexible, and companies and market segments that were traditionally wired, like utilities, transportation systems, are now beginning to use wireless technology. And so if we're using wireless technology for critical infrastructure, you have to protect the critical infrastructure just like you did in the wired world. Using cybersecurity, you need to measure it. Especially so in the wireless domain, because in the wireless domain, you're an open medium, and you're susceptible for interference and jamming. So the auto detection, the location of interference sources, is a perfect example where artificial intelligence can be used. It traditionally is a big data problem because we're collecting a lot of data. We can collect billions of bits of information a second as we're monitoring the RF domain. And of course, if we have multiple receivers looking at over a geographic area, you can just imagine the size of the data sets that we're given. Other things we're looking at, transmitter fingerprinting, so we can detect a specific transmitter. That really is useful. Using AI really improves that capability. Rogue transmitter detection, location, physical security. A lot of this is around the security front. Regulatory awareness. In addition to doing specific tasks, the artificial intelligence could also be used for automation. And that's a key attribute of artificial intelligence is to take what is traditionally, especially our RF monitoring domain, it is a manual process with RF engineers continuously looking at the spectrum to automate that process or at least augment the process to provide the RF engineer the ability to do other things while the system is detecting for any kind of anomalies or any specific things that they're looking for. Let's say looking for transmitters that they shouldn't be where they're transmitting where they shouldn't be, or maybe in the other case, people are not transmitting where they should be, so they're not meeting up to the regulatory commitments. Things of that nature. AI is a great tool for this. Now, when we're talking about artificial intelligence, and I'm guilty of this, but you'll hear the term AI, machine learning, deep learning, just to set the stage. And I think this is mostly how people consider these terms. So artificial intelligence is really any technique that enables a machine to mimic intelligence and logic. So you can use any programmable technique, you can use statistical techniques, you can use expert systems where you could have an operator or design a piece of software that will take will be able to automate a certain process by understanding exactly how an expert would operate that device or in that environment, looking at all different conditions. Or you can start looking at it from where one of the artificial intelligence camps was looking at how the human brain works and the concept of neurons and things of that nature. And they actually built on that thesis things like machine learning and deep learning. So what's machine learning? Well, machine learning is a subset of artificial intelligence that uses statistical techniques to enable the machines to improve the task with experience. So it's through repetition. They keep on learning, getting better and better and better. But the difference between machine learning and deep learning is the deep learning is a subset that the information that you're training the machine to do what you want it to do is based on the data that it's receiving. So instead of developing a program to tell the machine what to do, the data you're using, we call it training. The data you use actually is developing the program or developing the accuracy of the task, be it classification, be it prediction, or what have you. So it's the data that's actually that's developing the program in that perspective. And an example of this would be if we looked at, let's say, facial recognition. If I looked at machine learning, you would basically get pictures. You would get someone like a human or some kind of system to extract features, things like the distance between eyes, the type of nose, the mouth, and the different features around the face. And then you put that into a database, and then you can start classifying what attributes does this person look like versus the attributes of another person, and you can use that to recognize another picture of the same person based on on the features, and you'd use some kind of classification. Here it would be more of a statistical analysis algorithm. With deep learning, basically you're putting the whole picture in. You're not doing any feature extraction, but just by training the system with different pictures of the same person and of many people and telling the machine it's right or wrong as you're going through the training process. That's called error function and backpropagation for those that have done things like this. You'll be able to get a higher accuracy when you actually put a new picture in of somebody to determine who that person is. And that's how facial recognition systems are really built. Now, that was one example. That was a classification example. What people typically do today, I'd say for the most part, when you talk about not just AI, but when you're talking about machine learning or deep learning, they're using this technology, which is basically a statistical analysis or a probabilistic machine that I call it, is specific tasks. That concept is called narrow AI. And the task could be recommendations, could be classification, like facial recognition, for example. It could be prediction. If you're looking at, people have this dream of predicting the weather or the stock market or something, that's a time series information. So you use certain types of AI tools to help you predict what the next steps are going to be. So prediction is another system. You can also use it for anomaly detection. There's tools in AI that do that. And the list goes on around like transfer, what they call it, transfer art, where you can start using AI to create, art or image processing, things of that nature. How you manipulate images. And many applications actually do that today. A lot of those are narrow tasks, and that's what when we're talking about AI being deployed today. I think it's 95% narrow AI or tasks. However, there's a lot of research going on to improve artificial intelligence and make it more robust, make it more sophisticated. So improve the automation, having AI have more of a general knowledge capability. And that's true for natural language processing. Like a task for natural language processing today would be translation or text to speech or speech to text or conversational AI. Now we're getting into something that's a little bit more sophisticated. Now you can have basic conversations today. That's where we are in the task area. But as you start getting more sophisticated and where you can communicate with an AI as if you were communicating with another human, now you're moving into a new area. And also decision making is also another critical area. People are planning to use AI in the future. You can make some decisions today, but maybe not key ones, and we'll talk about why later on. So as an overview, and as you will see here, I'm not going to talk too much about the different types of algorithms, classical AI, deep learning AI algorithms, but we'll talk about the how one should address that when you're going through a product description. But what I want to talk about here today is kind of the overview. This chart's called the development overview, but really it's the system view. The development process will be slightly different than this, but I'll try to talk through it as we go through the slide. So basically, how an AI system works is that you're going to be collecting data from different sources, be it sensors, be it databases, be it information coming from SaaS tools or different tools, and it could be structured or unstructured. So that data is obviously going to be the input to the AI that you've already built. If you haven't built the AI and you're in the development process right now, well, you're going to collect a lot of data to train the algorithm to make it do the tasks that you want it to do. So there's a training phase. There's a validation and testing phase when you're doing this. So you need a lot of data. Now, when you collect data, not all data is treated equal or is equal. Some data you might have to clean it up. You might have to put labels on it if you're using supervised learning, for example. You might need to take out the nulls or zeros or change different types of parameters so the machine you're training can understand the data that you're having. So there's a lot of data management, and there's a big a realization for data scientists when they go through university. They dream about building all these statistical analysis tools and building all these fanciful machines and things, and they're only to realize that 80% of the role, and this is true, 80% of the role is going to be data conditioning. Doing the mundane, cleaning data, making sure all the databases are, they're getting all the right sources, putting the data in the right structure so they can train the machines. So that's the data conditioning phase. Then you get into the algorithms themselves. Here we have things called supervised learning, unsupervised learning. Supervised learning basically means when you are training the machine, you are giving the data a label. So if it's a cat, you say it. You literally have to type in this picture of this data set is a cat and a dog. Right? Let's say you're doing a classification between a cat and a dog, you would literally have to do that. And if you have 50,000 pictures of cats and 50,000 pictures of dogs, some dogs are in nighttime, daytime, backwards, frontwards, upside down, everything, because you have to train the AI to understand a dog in all these different contexts. You have to label it. And that's a big thing that's a big cost for data. Now, the unsupervised learning, you don't necessarily need to label the machine or the data going into the machine, which saves a lot of time. And there's certain techniques like autoencoders and reinforcement learning, but it still takes a lot of training, a lot of information. It still takes data, but you might not have to label it, but it still takes a lot of data. There's the concept of transfer learning. Transfer learning is if you've already trained an AI to do something, you have the certain weights and parameters, call it the parameters of the AI machine. You can transfer that to a new project and fine tune it to do something else. So an example, if you trained an AI to classify between a cat and a dog, and now you want to do a bear, you can use the transfer learning for the cat and dog because it's already trained on different aspects of animals and the structure of animals, and then you can retrain it on a bear, and that can save you a lot of training cycles. And from there, you have the algorithms going into human and machine interaction, and then the outputs, whatever the mission or the results are going to be. Now, a part of all that is what made deep learning possible, actually, compared to other techniques, is the ability to have huge computational capabilities, because the training takes a huge amount of effort. Huge, depending on the problem. Some problems are a lot easier, but in some cases, it would take you months and months to train on some techniques and some problem sets where that would be physically and economically impossible to do just a decade ago. So this is why deep learning itself has moved forward as an AI tool, rather than the statistical analysis or classical AI techniques that data scientists have been using for years. In addition to all that, once we've thought about all that, there's the thing called robust AI. So it's AI considerations. And we're going to talk a little bit about that, because you should have an understanding of some of the areas that one has to consider when you're building an AI. Is it explainable? Is it transparent? Are there any biases in it? Can you verify the results? Is it secure? We have an example here called counter AI. There is adversarial AI, and we're going to talk a little bit about that later. And also policy and ethics and training. And there's organizations now that are mandating certain sectors of products and services have policies and ethics to make sure that the AI and the application of the product has been certified to some degree. And certification can be just an internal checklist, but we want to make sure people are actually going through the checklist and considering it. Just like when you're building a product for security, people want to know, have you done pen testing? Have you put all the secure capabilities into the product? It's very similar to that context. Okay, so product managers. So if you look at the NPI process, so let's just say starting from the top here, just the beginning of the NPI process, new product introduction, you're defining the concept all the way to the product below. So the product manager will obviously have a good understanding of product awareness and market awareness and customer needs. So when we think about bringing AI tools into this NPI process, there's certain areas that we need to consider. Okay, so or certain tasks in the product management role, the NPI process, that there has to be new considerations, and this is what I have in the dark blue here. So during the problem definition stage, there has to be a consideration of AI, because the problem you're defining may not be achievable with AI. It might be another technique, but you won't know that until you start looking at the AI technology and tools box. So it's the problem and solution definition phase I grouped into one to say, this is going to be a little bit of an iterative process where you're defining the capability to solve a certain problem, but you might have to pivot a little bit in terms of what technology you use, or maybe how you define the problem. So if you came in very, fanciful at the beginning and said you wanted to have something that was super intelligent application to do this, that, you might find, oh my God, that's really going to be risky or not, or too costly to get. So you might define a subset of that to get to market. So you'll be doing that. On the product development considerations, when you're going from the product, so you define the product, you wrote your requirement specification, and the team's writing the system specification. There's a few things you've got to start taking into consideration, because now the development team's coming into the loop. You'll obviously have your AI team as part of this. they're going to be asking about data collection. You should start talking about data even before you get to this phase, but they're going to be saying, well, how do I collect the data? Where do we collect the data? Is it just from one source, multiple sources? Do I have to massage it? Do I have to clean it? All that good stuff, because that is part of the project now. You know, before you might have a software service, what you needed to do was write the code, define what the new standards are. There may be some adjacent market knowledge or whatever you were trying to develop, but in this case, you've got to take into consideration where you're going to collect the data, how much data you have, and hopefully, but this is where it comes insights, and this is where some understanding of AI development comes into play, is an intuitive understanding of the data that you already have, if that will be sufficient to meet the goals that you're trying to meet. And that will come through more experience than anything else. Then there's also the training effort. Okay, great, we've got the data, but it's going to take us many iterations just to do one test. Now, of course, because this is a probabilistic machine, this phase of development is the R, not the D in R&D. It's the research phase. Before you can develop anything and make a commercial product, you've got to research and develop the algorithm itself. Then you can put the wrapper code and make it into a product. But right now, this phase, from AI perspective, is a large R phase where you are testing to see if the algorithm works the way in which you specified it, the application should work. And of course, once you're going through that, you also need to consider all the AI items and like biases, for example. Now, I have something called here secret sauce. What do I mean by that? Well, it's a term that I kind of made up because when you're bringing AI into market, it really isn't about AI. AI is just a tool. What you're really doing is understanding how your product, your technology. So in the case of ThinkRF, it's around signal processing, RF engineering. How can an AI tool replace the signal processing software and do something it was doing, but from an AI context? Well, in order to do that, you really need RF engineers sitting next to AI engineers and kind of working together. Now, the way in which you build the capability between that domain and the nuances of that domain and apply them into AI in terms of features and training and performing certain tasks. And it's more than just data collection. You might actually have to process the data. Now, we do a lot of processing, but other fields do a lot of processing of the data to ensure that the information you're giving to the AI algorithm is something that will maximize or optimize the algorithm's output. What do we mean by that? Well, a lot of these machines work by understanding the influence of one set of data versus another set of data. And in order to understand how the features interact, you might have to do feature engineering. So in the case of some of the products we look at, or technology that we build, we'll look at how can I bring out certain features of the RF domain. I might have to do frequency domain transformations and convolutions and things of that nature in order to bring out the data specifically to feed the machine. That's the secret sauce that we have to consider. And the same thing is going to be true if you're using artificial intelligence for pharmaceutical engineering or even for business logic. You have to know exactly how it works. You just don't plug data into an AI. You really have to know that domain. But the understanding how that data can optimize the results of an AI tool is the secret sauce. Okay. So problem definition, very important with AI AI tools. Start off by always asking, how are we using the machine to enhance the user experience? Are we trying to make it more secure and safe, or useful, or make it faster, or totally new experience? And these are the types of things that you want to bring up, and you force yourself to ask those questions, because we've had people in the past. I've read a lot of articles and blogs about like management will come down to a product management team, a product owner, and say, "Where's my AI? I want my AI." Okay, what do you want to do with it? I don't care. I just want to make sure that we have, AI inside logo on our product line. And I'm being facetious here, but there's a lot of discussions in boardroom about, what are we doing? Are we taking advantage of it? Are competitors using artificial intelligence? Why aren't we? Well, that's not That's not the approach. The approach is how can we use AI to do something very, very specific to the product? Not how can we bring AI into the product? It's what are we trying to achieve, and can we achieve that capability or a new enhancement using artificial intelligence? You can look at the competition. You could look at how other people are using artificial intelligence in other domains to infer, some new ideas and concepts. So the other things that you need to look at is assess whether machine learning or deep learning techniques are the best way to solve the problem. Because AI experience is going to be required. So if you don't have it, you'll have to rent it and pay for it. But if you don't need to use artificial intelligence, then you make that decision up front. Good quality data and an expected which we talked about. And expect iterations. What I mean by that is you might go through an analysis using one artificial intelligence algorithm, and to go down the route for, I don't know, weeks, months, only to find out it's not giving you the results. So you got to flip and let's use a different AI tool. Now, I actually know some local companies that have dozens and dozens of tools they use to analyze their data and come up with results. And sometimes they actually have multiple tools being used for decision making or classification or for detection, and at the same time. And they use these tools to enhance the benefit of any single tool. So they might have a voting technique, or take 3 out of 5, whatever it is, of what the tools are saying. Because what comes out of AI is really a statistical probability. It basically is saying, like using the example we had before, is it a dog or cat? It's 100% yes or no. It's usually, if you give it a new picture, it'll say, yeah, that's a cat, 88%, because the output will be 88 or 0.88. That's the answer. So you got to make a decision. If it goes 0.65, is it a cat, or do you tell the user you don't know? But it really is a statistical issue. Okay. Unless you're doing prediction, we'll just give you a note and just leave it or not. Okay, the other part of artificial intelligence or using AI in product management role also applies to what I call the 3 Bs. This is a term, I'm not sure if this is a term many product managers use. I've been using this one for years, about how you go about providing or developing a new product or service from a concept. And you have 3 basic choices. You either build it, you borrow or OEM certain pieces of technology, or the whole thing if you just want to resell it, or you buy the product or service capability. So how do these apply to AI? Well, if you are going to build it, well, then you need to develop the AI capabilities from the ground up in your company if you don't already have it. So you either got to build a team, go out and hire people, or you can maybe bootstrap that activity through consultants, and then you have a future technology transfer agreement with them, and then you can build your AI team from there. But rest assured, this is not a consultant role where you're going to hire a consultant and say, okay, thanks very much, the product's built. No, you're going to have to establish an AI team and keep them, because now you have an AI algorithm in a real commercial product, which you'll have to maintain, and you might have to retrain. But you'll only be able to do that if you really understand the technology that you used. And there's many technologies here that you use to build that product or service. Now, if you go down the borrow route, then you can OEM, let's say, a classification engine or a prediction engine that you can build into another service or a larger software application. In that case, as long as you agree with the OEM vendor what the inputs and outputs are, then you can integrate that in your product. And then you can say we have an AI-based product, but and of course that could be a piece of software you drop in, or it could be a SaaS service. And you'd be surprised how many services are available today that actually you think you're getting from one vendor, but actually when you're actually doing a specific activity, it's going out there with other SaaS services and pulling in the data or processing data in different sites through OEM agreements. The third way, of course, acquisition. You can go out and just buy the company and buy the knowledge. or just buy the knowledge, if you will. But when you buy a company or buy a tool, you're not just buying the application, of course, as you know. If you're buying something, you're buying the team, right? You're buying the team because that's what you, at the end of the day, is what you need to do. Okay, we're going to consider some of the or think about some of the considerations for products. One of the interesting capabilities, if you build it right, for AI is the ability to automate a process, automate a task. But there's some considerations around that. One is, well, if the machine we build it makes a decision and there's a high consequence of that decision, well, that's going to be different than if it's something that's not so impactful. The other thing that you have to consider is the confidence level of the machine making the proper action. If you build something it's guaranteed, it's always going to make an easy decision. It's a very simple artificial intelligence engine, or we're maybe using an old statistical technique. We've got a lot of clean data. It's very simple for it to make. That's one thing. But if the confidence level is low, and they're just because, or lower, because there's so many parameters, so many boundary conditions, or different permutations of what could happen that, we think we got it right, and it's mostly right. Well, you got to be careful how you automate that, especially if it has some impactful consequences to humans or property. So if you have a high confidence and low consequence of the impact, then that's great for machines. Any kind of machine, including artificial intelligence. If on the other hand you want to augment the process or try to automate the process as much as possible, but you're kind of concerned about the impact and the level of accuracy of all the conditions that the machine will be addressed with or faced with, then you probably want to have a machine that is augmenting a human. So we call that process augmentation in the business world, but it applies within artificial intelligence, where you would want to make sure that there's a human making the final decision. So the AI can be designed to provide the human information and simplify humongous amount of tasks and research and whatever, and just provide the human information in the best optimized way possible so the human can make a decision. Or you don't want the human to, you want the machine talking to the human at all, and you want the humans to only do the specific task and not using artificial or very little in artificial intelligence. So that's a consideration. Another consideration that you hear a lot about is ethical AI. And it's not one thing, it's many things. Ethical AI includes privacy and security. Privacy on the front end, which would be the training. Are you using private data to train your machine? Where are you getting access to that data? Should you have access to that data? If you're training a machine, where do you store that data? Are you allowed to even have access to it? There's a lot of healthcare services that have private data to run these new AI machines for all the different processes, making maybe helping diagnostics and things of that nature. But legally, the people who are training the machines, the computer scientists and the engineers, don't have legal access to that information, so they have to find ways to get that information. But after doing that, on the back end of this, when you build an AI, you got to make sure security and privacy is also maintained. Because it is a probabilistic machine, and it's like we're talking about before, garbage in, garbage out. You can develop unfair biases, and many of them will be unforeseen consequences. You might not have any idea that it was biased until you actually start testing all the different ways that all the data sets or all the all the interactions that the machine will see. But you have to test for that. You got to make sure you're looking at that. Transparency and explainability is very important. Unlike traditional software programs where you can look at the program and say, well, we made a decision over here, it was an if-then statement, we looked up, and in this case, you're actually training the machine to make a decision based on information you gave it in the training phase, and you told them when it was wrong, you told them when it was right, and based on that, it came up with a internal quote-unquote algorithm. That's hard to explain. When something comes up and says you're using artificial intelligence to help the bank make a decision if someone should get a loan or not, and they applied, they filled out 3 or 4 or 5, 10 pages of data, and the answer came back no. But why? Well, you got to explain why, because that's the law. You got to explain why. So in addition to that, there's a lot of work going on in AI research to help make the AIs a little bit more transparent. Accountability, reliability, safety, and safety is obviously something you want to do for all products, but applicable here too. And when it comes to value alignment, inclusiveness, human-centered, and governable, a lot of these are coming up because of the automation capabilities of AI, and sometimes the decision-making process that the AI is allowed to make on its own. Now, when you talk about ethical AI, people will talk about it in that context, but not many people will say, well, why is this the case? And it's good for the product manager to understand why there is a concept of AI ethics. Like we didn't have a concept of AI software. Well, I guess we had software development AI. It would be the engineer. You put your hand on your heart and start the book and says, yes, I'm going to build good products for for humankind and all that good stuff. But with AI, because of automation, there's some interesting reasons why people are very concerned about this. So, for example, because the software, an AI program, is really developed by the training data, it is a probabilistic machine. And it's not a fixed decision like in a lot of software. And it's hard to get software right, even though it is more of a deterministic machine. It's really hard to get right, and there's bugs and fixes and everything going on, and race conditions and buffer overflows and things of that nature. And that's a deterministic machine. Well, in AI, it's a probabilistic machine. So people are very concerned about it making decision and right decision based with the data that we give it and the expectations we plan to get out of it. There's also another reason, because of the computational requirements are so high, you can't always build an AI forever. And to make sure it's 99.999%, you're going to have to cut it off at some point and say, that's probably good enough for this use case. So another reason people want to make sure that when people are building AI, they are looking at that as well. And of course, why do we care ultimately about this? Well, it's not only just making decisions, but it's automating processes where humans were in the loop before, and humans can have more discretion, and you can interact with the human. In this case, you can't interact with a machine when it's necessarily, unless it's designed to do so, but many of them, the tasks are not. So there are more and more groups forming to talk about ethical AI. They're all over the map right now. But the groups that you should consider is the groups associated with your domain. So if you're in the healthcare, you should go to your healthcare standards and ethical AI around that. Because at the end of the day, you want to get internal certification associated with the domain you're selling it into. And the same thing if you're in telecom, or if you're in autonomous vehicles. There's going to be different domains that are looking at standards and regulatory approval that will have an ethical AI standard for that domain. But it will be beat up something very, very similar to this here. Adversarial AI, another consideration. This is kind of the fun thing. So what's adversarial AI? Well, after you build the artificial intelligence machines, and people have found ways to exploit them. I have a couple of examples here where they're around image classification or captions, image captions. And if you know how a machine works, after it's been trained and it's working effectively, if you know enough about the algorithm, you can fool it without making it obvious you're fooling it. So in the case of the stop sign here, you can see that there's some pieces of tape, black tape and white tape on a stop sign. You would look at that and say that's a stop sign. But because of how the machine was trained and the data was trained and the algorithm that it's using, the engineers reverse engineered it and came and said, if we put the tape in these spots, it would actually fool that algorithm to make it so it couldn't detect that it's a stop sign anymore. Now, you might say, okay, well, how many people on the street are going to know how the algorithm is? And I think, well, I don't know. I mean, there's information going out, but the point here is that it's possible to do that. okay, something seemingly innocent can actually have major ramifications. The example below is a very interesting one. So you have a large panda. The AI application said, yeah, that's a large panda, 99% accurate, that's a large panda, with using the bitmap of the picture. But if you introduce some permutations of some noise, the way it looks like here, and the output of that looks like what's on the extreme right-hand side, to a human would say, well, it still looks exactly like a panda. I'm looking at everything. I don't see any kind of noise or permutations. It looks exactly the same, but to the AI, it can't detect that it's a panda. It actually detects it's a bucket, which is unbelievable. But that's the way AIs work behind the scenes. So that's a little bit of insight for consideration. Other technical pitfalls you'll hear about is overfitting and underfitting training. So even though I've been using the term training throughout this presentation, saying you need to train the data, but it's sometimes you can't train it as effectively as you want to. And you have also noisy conditions, modal selections, like all sorts of things on the technical side that you have to consider. We won't go into too much of detail in there, but you can see it from here. Organizationally, you need to make sure that some of the pitfalls is accessing the right AI skills, R&D alignment, because now you're introducing AI into the R&D process. And there's also upkeep for the product itself that one has to consider. And this is my last slide. So basically, if you want to continue reading this, there's a couple of options here. One, you can take some online courses. You don't have to focus on the detailed programming, AI, Python, and all that, but you can take, there's a number of high-level courses online from top universities, Coursera, Udemy, that will teach you about the application and about AI, and that will give you a good rounded, at least introduction to artificial intelligence, which you can apply to a product management role. And that's all I have for today. Thank you.
Well, thanks, Cliff. Excellent presentation. Just a time check. We are at the witching hour, so we're all going to turn into pumpkins. I guess we could put it, there's been quite a lot of questions there, a lot of very, very interesting questions. And so if people want to stay behind, I don't know, Cliff, can you stand behind for a few minutes?
Yeah,
or
I'm good to 1:30.
Okay, well, hopefully we won't go that long. But what I'd like to do before we wrap up is just to get Amanda to give us a preview of the event in March, and then we'll come back to do the Q&A. For those that can't stay around, I understand that. What we'll do is put the Q&A in like an email bulletin, and we'll share it amongst everybody that's participated, because I think there's some really good content in there. I'm looking forward to seeing the answers. Amanda?
Awesome. Can you hear me okay?
Yeah.
Okay. So just a quick preview. We are going to be joined by a number of organizations who have agreed to participate in a manufacturing panel. And we're going to be reviewing similarities and differences so that we can get an appreciation of life in a manufacturing context for product management and product marketing. So it's an opportunity for us to connect with organizations and peers in organizations outside of the software domain, where we do have a heavy representation at OPMMA. And looking forward to having a wonderful panel discussion and opening up for an Ask Me Anything format at the end. So thank you again. You know, we continue to have awesome Ottawa participation and volunteering, and hope you join us in March. There will be another organization that we will be announcing, but until they responded formally, you know, I didn't share their logo. So looking forward to it, and yeah, hope to see you there.
Okay, thanks, Amanda. Just to put a limit on this, I'll go. We've got 7 questions, and we'll set it till 10 past. So we'll just go another 10 minutes if people want to stay, hang on just to hear the answers. So I'll go first. We've got a question from Peter McKinnon, and the question is: do you use explainable AI, and if so, how?
When you say do we use at ThinkRF, no, we don't use explainable AI right now, because the context in which we use it, it's really it's a very technical task that we're doing. So for example, if we're doing interference detection we are just letting the operator know that there's an interference source here. So we don't have to explain to a human why we made a decision on his behalf that could impact his benefits or not, like that. So we're not using it right now. Now but later in our roadmap, we will be we can conceive us using spectrum data to actually make decisions that could have an impact directly with humans, and that's where we'll have to hit that perspective.
Okay, thanks, Cliff. I'm sure that Peter can follow up with you later if that doesn't satisfy his curiosity. Question here from Nathan. It's a long one. So he's interested in hearing more about supervised learning at scale. He sees things like reCAPTCHA as being used to digitize books as an effective example of supervised learning at scale, but wonders about the cost-effective options for companies that aren't really Google-sized. And actually, Tomo weighed in then and also said CAPTCHA was also used to label images for self-driving cars.
Yeah, so in that question, Andrew, he said he's doing what, bots or something?
He was asking really, is there a cost-effective supervised learning?
Yeah. Okay. So there can be. So when you're collecting data, you can automate the data collection and have a system actually put the label on certain things, if you know exactly what it is. But if you're doing image, a lot of data you collect, it has to be done manually. So if that's the case, cost-effective way, there's actually companies out there you can outsource to that do that hire humans to do data labeling around the world. So
I think Mike suggested, I don't know whether he was being serious or not, but he suggested could he get dogs to do some basic recognition.
Yeah,
I think it would be very cute and very cool.
So long as it was only sausages and biscuits, should be fine. Anything else?
Exactly.
Okay, David Brown asking, will long-term product support of AI-based products present any new challenges?
Yes, very much so. This would be the equivalent of doing a bug review. So a customer comes in with a problem. Let's assume it's not a hardware issue; it's a software issue, and you give it back to the development team. You try to recreate the problem. Is the first thing you want to do if you've got a bug coming in from the customer. You also do the same thing with AI. It might be a lot more complex because the customer's environment in which it's used, it was using, let's say, 100 different inputs, 100 different features. So how to replicate that's going to be really interesting. So when you're building the product, what you want to do is kind of capture those conditions and at least have the customer try to reproduce it himself and hit like a record key so you can see what parameters were coming in during the inference stage. So this is not training anymore. The machine's already trained, it's being used, but it still can have a lot of inputs into it. So AI is not just used on the front of a camera to make a decision. It can be used in front of hundreds of cameras or hundreds of sensors or hundreds of data inputs and making decisions. So you can imagine this massive permutation and how can a manufacturer reproduce this? But then one argues, how dare they produce a product that has a permutation to not work? But like I said before, you have to cut it out. You have to cut it off at some point and say it's doing what you expect it to do under these conditions, and you test it as much as you can. And you can automate testing as well, but maybe some limits.
Thanks, Cliff. I have another one from Peter, but I'll put that at the end because he's already had one question. So I'll go to Colin, one from Colin here. Is it really worth anyone other than Google/Microsoft/ a university building an AI system rather than using an AI system? I feel it's like building your own database.
Yeah, so there are AI tools out there that you can use, and they can do certain things. Like, for example, if you run in Azure or Google, there are AI systems you can use out of the box, and that you're trying to use it. However, if in certain domains, like technical domains, RF engineering, a lot of engineering disciplines, pharmaceutical, and even some business context, those machines might not give you exactly the ability to fine tune them. We didn't get into the technology here today, but there's concepts called hyperparameters. There's ways to fine tune the machines to avoid what they call local minimums, and to get the results you want. You might not get the results you want using an off-the-shelf machine. You might actually have to go in and tune the machine. It's a little bit different than the database. The database is quite structured. It's more of a deterministic machine. This is a little bit. So this is where science and art meet. Let's face it. So this is where science and art meet. So there's a lot of intuition you have to develop when you're developing artificial intelligence and how to get them to run properly.
Okay.
But if you're doing simple things, like if you're going to build a chatbot, don't build a chatbot. There's a lot online. Okay.
Yeah.
If you want facial recognition, they're already online. But people actually built it from ground up, but you can use that service. But if you're doing something very, very specific, like we are, if I'm doing a signal transmitter detection, there's nothing to buy online. I have to build it. So it all depends. If something's available, I'd say use it. If it works, use it. If it doesn't work, you're back to building it.
Okay. One final question. We'll go back to the one from Peter. You may have answered this in your presentation, but I'll ask it anyway. Do you use a generative or adversarial network GAN approach to your machine learning?
We are in one of our projects. We're using a GAN for transmitter fingerprinting, and we're using GANs for what they call data augmentation. So GANs are used for many different tasks, and one of the tasks is to help to create a larger data set than you would have otherwise had from the original source. And so we're using GANs in that context. So on the training side versus the inference or the use side. I'm surprised we didn't get any questions on AGI, general intelligence, where AIs take over the world. Are people concerned about that?
I do have one actually on ethical. I'll finish. I'll make that the last question because a couple of people, including Hala, asked about ethics. So this one's from David Brown, relating to testing again. It says, do you revisit testing with respect to ethical concerns later in the life of an AI product?
Well, you need to, and that's one thing I said during the presentation. It really is an iterative product support activity. So depending on the artificial intelligence, you might have to periodically retrain it because the data sets might actually change. Now, there's one limitation in data sets. I don't know if there's any people in math that like math here, but it's called a stationary distribution. So when you're training an AI, it can't be random data coming in. There's a concept called the stationary distribution. It could be random, but there's some structure to the randomness, if you will. So if you are, if you're the media or the environment that you're using that's as an input to the AI changes in any great way, or even in small ways, sometimes you'll have to retrain your AI. So there's a constant improving and constant checking. So that's what I would answer that. If the environment doesn't change, then you won't need to retrain your AI as much.
Okay, then, Cliff. I think we'll call it a wrap there. We've gone 11 minutes over. So there's still, I think most of the questions now remain were the ones that we've asked ourselves and from OPMMA, but I think they're of general interest. So as I say, we'll summarise all of this and maybe if you could help us with some short answers, and then we can maybe keep the conversation going for a little bit longer. So with that, I will call an end to our February networking event. Thank you everybody for joining us. A big thanks for Cliff. Another very engaging, interesting subject, which I'm sure we will revisit in many ways over the coming months and years. So with that, thank you everybody. Have a great day.